this section is really easy. The only hard thing about it is probably the thing that you will struggle with is the language as much as anything else. The title is Functions as a Rule. The way reading this section, going through it, the way I interpret is this. How many of you remember seeing something like this in Algebra 1? Okay? This is a function of x. It's just written in a form that you're more used to seeing. You guys remember having a table, making a table to graph it or something, and saying, okay, put -1 in for x, 0, 1, and 2. You guys remember doing that? So what we do is when x is equal to -1, we put it in here and find what y is. That's a -3, we get what? -2? Does that look right? And that's an ordered pair. Agreed? X, y. Then you do the same thing for when x is equal to 0. You get y is equal to 3 times what? 0 plus 1. The answer for y in this case is 1. So when x is 1, what do you put in? 3 times 1 plus 1. You get y equal to what? And for the last one, we'll put x is what? 2. So y is equal to 3 times what? 2 plus 1. So y is equal to 3 to the 6, 1 is 7. Okay. All of those represent ordered pairs. What they mean in this section is this is a function of x. Okay? This is your rule. That y will always equal 3 times whatever x is plus what? 1. That makes sense? That's the rule. That's the pattern here. It creates these ordered pairs. So if you look at the top of page 39, come in. Let's look at the top of page 39. When they say x and the rule is what? 2x. What they mean is that x transforms into 2x. If we were to write this one like this, it would look like this. X, and then your rule would be 3x plus 1. Okay? In other words, if you just think of in terms of x and you don't have a y, another way to write this would be like this. It's like we're going to change x from 3 times whatever x is plus 1. So x changed from -1 to what? 2 under this rule. X changed from 0 to what? 1 under this rule. X changed from 1 to what?
4.
X changed from 2 to what?
7.
And y is what it changed to. What you're used to seeing is we get a different variable for what this rule changes y into. Okay? What this is a different form of the same thing. This function we just did was y is equal to 3x plus 1, correct?
Yes.
Another way to write it would be x transforms basically into 3x plus 1. X changes from x to what? 3 times whatever x is plus 1. The other way to write it is in function notation. This function of x is equal to 3 times whatever x is plus 1. all of these mean the same thing. Okay? It's just a different way of writing the same thing. It's like three different languages there. Or we're going to say it's three different notations. They all mean the same thing. X starts out as a number, then gets plugged into this, and it spits out a different number. Okay? Just as up here, X started out as negative 1, and it spits, once you put it in, it spits it out as what? Negative 2. The function is 3 times whatever you start with plus 1. That's what it's going to change every time. Okay? You guys are just so used to seeing X and Y, you don't realize that this is a function of X, that X is changing to negative 2 basically, and we're giving Y as the new X, in essence. Okay? So what's going to fool you more than anything in this section is that we're going to do it in these different notations, but what you do doesn't change. If I give you numbers for X, what do you think you put it in for? You put it into the equation here. Let's do another example. Let's say I had this. I'm going to give a set of numbers 0, 1, 2, 3. What do you end up getting for your new numbers? When you change X from X to 10X, what happens? What are you going to do each time here? Everybody watching, write it down in just a second. What's going to happen here? X, it starts out as X, then it changes to what? 10X. So if I start out with X0, 10X would be what? 10 times what? Which would give you what? So this becomes what? It stays the same. However, when X is equal to 1, what do you get? 10 times what? 1. So 1 becomes what? 10, doesn't it? You guys see what I'm saying? What does the 2 become? What happens? It'd be 10 times what? 2. It becomes what?
20.
What does, when X is 3, what does it become?
30.
See how it's like you're putting it into a machine and spitting something out? In this case, the machine multiplies it by what? 10. That's what a function is in essence. That's why a function doesn't work, you know. If a machine works properly, if you put a 10 in, you always ought to get this out as an answer, right? If you put a 10 in another time, you get something else, something screwed up with the machine, isn't it? You kind of see what I'm saying? I mean, that's how you can think of it. So that's why if a function, if the X repeats, it doesn't work, but if the Y repeats, and as long as there's only one value for what you put in, you always get the same thing back out, then it's a function. Okay? If you put the same thing in and get two different things, then it's hard to predict what it's going to do, right? I mean, how many of you want to push on the gas pedal and go backwards? Agreed? When you're in forward. Now, when you're in reverse, see, you changed the X to what? Reverse, then you pushed on the gas pedal and it went what? Backwards. That machine wouldn't work very well if you put it in reverse, pressing the gas pedal, and you went what? Sometimes you go backwards, sometimes you go what?
Forward.
Yeah, I don't want to drive that car. Okay? But the point is that that's why things are a function. If what you put in gets the same thing, gets exactly this one thing out every time, then that's fine. That's why you can say it's a function, it's a machine, it works. I can predict the outcome. Okay? It is not a function if you put 0 in and get 2 or 3 different answers for it, because you can't predict the answer. So, all concept aside, that's really all this section is. Now, this is no different than this. Is this not the same notation as this? If X was 1, what would f of X be? F, and what we do is we say f of 1. In other words, what is X? 1. What would it be? 10, right? It'd be 10 times what? 1, which would give you 10. Does everyone agree? If x was 2 for this function, it would be f of 2, where you put 2 in, it would be 10 times what? 2, which would give you what? 20 is the answer. Do you see how this is the same thing as this? We're just throwing it into the function, getting out what we get. And the nice thing about function notations is you don't really have to say x is equal to 3 over here to the side, because you say it by putting a 3 inside the parentheses, don't you? What you're saying is in this function, put what? 3 in for x. So it'll be 10 times what? Which gives you 30. Okay? The domain is what you what? Start with, the things you're putting into your function. The range is what you get up. What? What you get out after you put that in. Okay? Which is what we talked about yesterday as well. So for number 1, they want to say, calculate f of x for the given domain. What are you going to do? You're going to plug in 1, then you're going to plug in what? 2, then you're going to plug in what? 3. Then you can plug in 10, then you're going to plug in 100. I need to see you plug that in here every time. I know you can do it in your head. I understand that. But all I need is this right here. That's not so bad, is it? I want the notation written out properly. This is okay to me on these easy ones. On ones that have more than one step, I'd like you to go ahead and work your steps down. Okay? The other thing is, okay, the domain is your independent variable. Okay? The range is your dependent variable. Now, why is that? Independent means out on their own, right? No matter what this function is, 0 doesn't change because it's what I started with. It's independent from whatever the function is. 1 doesn't change, it's independent. But what's dependent on the function? The range. If I change this function, would the range change? If I change this from 10x to 3x, would the range have changed? Or would the domain have changed any? No, that's why these are independent variables, and the range is what? Dependent variables. Okay? Because the domain, you can change the range, you can change the function, the domain won't change, but the range will, right? Because you're putting it into a different machine now, and therefore spitting out a different answer. Okay? Let's get started on this so we can ask questions if we need to.